Okay, so in this video, we're going to talk about rational exponents and radicals. Rational exponents are simply fraction exponents, okay? So you're going to see a fraction in the exponent instead of a whole number or integer. Radicals are this symbol. You know it as the square root sign, okay? But we have more than just square roots. Back in 8th grade, we talked about cube roots, okay? You can have a 4th root. You can have a 5th root. Okay, you can have up to 100th root if you really wanted to. So remember, a square root is what number times itself 2 times will give me 25. A cube root is what number times itself 3 times gives me 125. A 4th root, what number times itself 4 times gives me 81, so on and so forth. You figure that out. You're going to want to know how to do these on your calculator. Okay, you'll have to probably send me an individual picture of your calculator so that I can show you, because every calculator is very different as to how to find that root button. All right, so let's kind of talk about a couple we know. 25 to the 1/2 power is equal to 5. Okay, so I'm taking 25 to the 1/2 power. You know that the square root of 25 is also 5, okay? 8 to the 1/3 power is 2. You may or may not know the cube root of 8 is also 2, okay? And I'm going to give you another example. 81 to the 1/4 power is 3, and the 4th root of 81 is 3. Do you see a pattern here? I sure hope that you do. Basically, taking something to the 1/2 power is the same thing as square rooting it. Taking something to the 1/3 power is the exact same thing as cube rooting it. And taking something to the 1/4 power is the exact same as 4th rooting it. So let's say you don't know how to find the 4th root of a number on your calculator. You could plug this in instead. You could take 81 to the 1/4 power, and that's going to give you the exact same answer. So in general, okay, if you take something to the 1/2 power, that is the same as square rooting it, and vice versa. Square rooting a number is the same thing as taking it to the 1/2 power. Taking something to the 1/3 is the exact same as the cube root of that number. To the 1/4 is the exact same as the 4th root, and vice versa. To the 1/5. And you can see that this will continue for all roots. Okay, notice how it's 1/2, 1/3, 1/4, 1/5. We're going to talk about what happens if that numerator is not a 1. Okay, but for right now, if you can think of it this way, that's going to be extremely helpful. Okay, in fact, you can write any. Okay, I can take any base to a rational exponent. So a over b is just saying, hey, it can be any fraction. A and b can be any number. Obviously, b can't be 0 because you can't have 0 on the denominator. What happens is when you go to write this as a radical, x is my base. The base is going to stay the same. I'm going to put x there, okay? My denominator becomes what root I am taking, okay? So if b is my denominator, I'm taking the b root, whether b is a 4, 5, 6, whatever it is. A is your power. It becomes your exponent. So x to the ab power becomes the b root of x to the 8th. So for example, if I had x to the 3/4 power, x is still my base, 4 is on the bottom, means this is a 4th root, and 3 on the top means x to the 3rd. So I'm taking the 4th root of x to the 3rd power, okay? Now, that was happening here, okay? Let's look at this one. My denominator became my root, just like it did here. My numerator did in fact become my power, but x to the 1st is just x, so I didn't bother writing it. Okay, same thing here. So this is a 4th, became the 4th power. 4 is on the denominator, it became the 4th power. And again, I am taking x to the 1st power, but there's no point in writing that because x to the 1st is just x. Okay? Here, x to the 3rd is, well, x to the 3rd, so I have to have that exponent there. So in general, your base stays the same, your denominator becomes what root you have, and your numerator becomes your power. Now, there are some more vocab words. This is called the root, but some people, or the book, it's also called the index. Okay, what root you are doing is called the index, and the base is also called the radicand. I am not going to directly test you on these words, but I just want you to be aware that that is also what they are called, okay? So, as you can see, this fit that as well. So let's just do a couple more examples. If I have x to the 6th sevenths, okay, x is still the base, 7 is my root, 6 is my power, okay? If I have x to the 9/5, okay, it can be an improper fraction. X is my base, 5 is my root, 9 is my power, and it can be that simple. Now, if I have something like this, 2x to the 3/4. This is still, my base is the entire thing 2x, so I want to keep that together here, okay? 4 is my root, 3 is my power. We will simplify this. We're going to learn that kind of more in the next video, that can be simplified, but for now, just think of it like that's all you're doing. But the base is the entire thing, it's the entire quantity 2x because of those parentheses. Now, if I gave you this, we don't have parentheses here, so 2 is not part of my base. This is actually 2 times x to the 3/4, which becomes 2 times x is my base, the 4th root of x to the 3rd, which I can then write together without the dot in the middle. So just be careful, just like always, with the parentheses versus the parentheses not around it. Now, this works the other way. So I can take something from a rational exponent and write it as a radical, but I can also take a radical and rewrite it as a rational exponent. So, for example, let's do, if I have the cube root of x, okay, technically my power is 1, x stays my base, my numerator is the power, and my denominator is the root. So that becomes x to the 1/3. If I have the cube root of x to the 7th, again, my base is x, it stays the same. My numerator is 7, my denominator would be 3. So that becomes x to the 7/3 power. Here, if you don't see a number, you'll notice back earlier in the video with the square root, I did not put an index there. I didn't write the 2. With square roots, we don't have to write the 2. We assume that if you don't see it, it's a square root. Now, if it makes you feel better, you can sure write that 2 in there, but you don't have to. So this is now x to the 4. That's my numerator. So my denominator is 2. If you look, this can be simplified. 4 divided by 2 is 2. So this is the same thing as taking x squared. Okay? And you could have okay, so x is my base, 4 is my numerator, 6 is my denominator. Like any fraction we've ever dealt with, I can simplify 4/6 to 2/3. So that becomes x to the 2/3 power. Okay, I'm going to talk about simplifying just a little bit in this video, and then we will move on. So I'm going to go back to some more where you can write it like this. So I'm going to go back to that example that was 2x to the 3/4 power. like I said, that becomes the fourth root. We're going to keep that entire thing and to the third. And if this was the test, this would be a 2.0 level. You could stop here. You can, however, use our property of exponents where I can take both of those individually to the third power. And so this becomes the fourth root of 2 to the third is 8, and x to the third is x to the third. So I could take that one step further and go ahead and distribute that power through, since that is multiplication in there, and I could simplify it down. So that is the basic of how rational exponents and radicals are related. In the next video, we're going to talk a lot more about things like this and how to simplify them.